So the previous video we're using the unpack BCD. The unpack BCD actually using 1 byte to represent one ASCII value. So here we talk about the other example is the packed decimal integer. So the packed decimal integer actually they're using the 1 byte for 2 decimal digits. So you can understand why we can do that, because 1 digit for the decimal number is 0 to 9. So at most you only have 10 digits. So in order to represent 10-digit value, you only need to have 4 bits. So that's why we can consider each decimal value we can using 4 bits to represent for that. So since each byte we have 8 bits, so that's why each byte we can have 2 decimal digits to display. So for example, if we want to display 1, 2, 3, 4, 5, 6, 7, 8, we just using the 4-byte sequence in the hexadecimal like this. So that's why we call they are the packed BCD. So actually their result is they will just direct to display in the hex format, right? Because the hex format anyway, when they display in the screen, we don't know that hex or they are ASCII or the decimal, because for human we read as 1, 2, 3, 4, 5, 6, 7, 8. But in the calculation system, we can just consider they are hex. So we'll see what the operation for. So the first one we call the DAA, that's for the addition. So that means they are the decimal adjust after addition instruction. Because like earlier we say, our pack BCD is to use the hexadecimal to represent the decimal digit, and 2 digits can display in 1 byte. So that's why here when you do the DAA, that means you're using the decimal in the hex format to do the calculation. But the hex is every 16, they will carry over 1. But decimal actually is 10, right? So that's why we need to do some adjustment after your addition and subtraction. So this instruction will convert the binary result from your addition. The addition can be either add addition or add with the carry flag operation. So the first thing is the value to be adjusted, they need to be in AL. So that's why you call DAA, they will just work with the AL. So the logic underneath, actually they is using the accelerate carry flag. So if the lower digits, you need to be adjusted. So the accelerate carry flag, they need to be set. So if the upper digit need to adjust, the carry flag is set. So did you remember these 2 carry flag? Did you remember before when we talk about the status flag, we talk about the carry flag. Carry flag actually is work on the every byte. You see they have carry over or not. But then we also have accelerate carry flag. They are the lower 4 bits if the 4th bit they want to carry over 1. So that's here we will use that. Because now each AL, actually they can contain 2 decimal bits. So that's why we need to process 1 by 1. So that's why we see, for example, we do the 35 plus 48. So when you consider 35, actually we just read each ASCII value is 3. So then I'm using this 3. That should be 33, right? But I only have using the lower one I save in the 3. So then the 5 I save in the 5. So that is 30. For human, you think about is 35 decimal. But here we just write in 35 hex. So then we move the AL in 35 hex. So then on the other one, we just add to, that's a 48 hex to the AL. So that's why you see your result need to be in AL. So after you do the DAA, you see 35 plus 48 supposedly is 80, it's not 80, it's 5 plus 8 is 13, right? So 13 is D, right? So suppose if we do the hex addition, add, they will really work on the binary system. So that's why they really do the addition is 7 and D. But for human, for us, we cannot really see they are 7 and D. We need to see is 83. So that's why the DAA can convert the hex calculation back into the decimal form, kind of we want. So after we have the 8 and 3 in hex, but then one thing is you can see how you will do, right? So you just OR each one with 3 0. So that's why they came back to the 83 to display in the screen with ASCII value. So the same thing, you will see 35 plus 65. So suppose it should be 100, right? For us. But because they are in the hex display, so 5 plus 5 is 8, 3 plus 6 is 9. So that's in the 9A in the hex system. So the DAA can help us to convert that become the decimal system. But one thing is need to be careful, right? If the carry flag is set, you should know 0, 0 is not enough. That means we need to have one more bit for the carryover value to display correctly. So that's the DAA example. For the DAA example, the logic behind the DAA instruction you can try to see here. Because remember, the logic behind here, if you are interested to read the logic, you can try to read about that. But I just quickly to explain about that. The reason is we using the hex to do the calculation. So the hex is every 16 we do the carryover. So that's why here your DAA just need to kind of readjust that 16 carryover back to the decimal system. So that's the logic about the DAA. So this one is if you want to implement DAA instruction, so that's the logic you need to use. So that's the DAA. So the other one is DAA is for the addition. So the DAX is for the subtraction. So the DAX actually is just the subtraction, decimal adjust after your subtraction. So again, your subtraction can be regular sub or sub with the carry flag. Again, we only adjust the value in AL. So we see the example. For example, if your BCD is 48 minus 35, so you will save AL is 48H, sub 35H. So suppose the 48 minus 35 is 13, right? Yeah, that's 13. So very good. Even after your DAX, you still equal to 13. So the carry flag is 0 because you didn't borrow anything. But then you see here, when you not borrow anything, hex and decimal, they are the same. But now if you have 62 minus 35, in decimal system, 62 minus 35, the answer is what? It's 37, right? You need to borrow, so that's 27. Okay, it's 27, right? But now if we're using the hex system to do the subtraction, they will be 62 hex, 35 hex. But 2 minus 5 is not enough, right? So we need to borrow. But 2 after you borrow become 2 plus 16 become 18. So 18 minus 5 become 13. So 13 is what? It's D, right? So that's why you see sometimes if you need to borrow, but your result in hex is 2D. So that's why we need the DAX. So after your DAX, they will convert that back to the 27. So that's the example why we need to use our DAX. So for all the example for these three, the DAX actually they all have the bigger number minus the smaller number. So that's why they are all positive. But sometimes if you see here, if you have 32 minus 39, actually they are negative number, right? But actually they won't be negative because we are only using for the unsigned integer to do the calculation. But one thing is, if you really need to do a subtract because you don't have enough, so the carry flag will be set. So that's why according to the carry flag is set. So the DAX, they also have some other algorithm how they will deal with that. So that's why sometimes after you do your calculation, the same thing, even you do the DAS to convert the decimal to back to the decimal from hex, we still need to check the carry flag. Just like your addition, if that carry flag is set, that means you need one more digit to show the correct value. So on the other hand, when you do the subtraction, if carry flag is set, that means your number here is incorrect because they need to borrow. So about the DAX logic, the same thing. Here is the logic. Because one thing is when you do the hex subtraction, they have 16 as the one byte, one digit to borrow. But here we need to convert that back to the decimal system. So this two is about the DAX and the DAA, about how to adjust the decimal calculation using the hex system. Work on the packed decimal number.